All right, let's look at balancing chemical equations and how we go about actually doing that. First, we're going to need an equation. So let's say we burn some magnesium ribbon in oxygen. That looks like this.
Oh, it's not as cool as what I thought it'd be.
That's cool. That was cool.
So as you can see, we get a nice bright white flame. When we burn magnesium, it burns very nice and brightly. Your teacher will say, don't look at it when it's burning. And of course, students tend to look at it and then complain that they're seeing dots afterwards. It's like, yeah, well, we told you, don't look at it. Anyway, when we burn this, we get magnesium oxide form, this white powder. Now, here's a reaction equation. It's actually not correct at the moment. Oxygen is diatomic. It comes in pairs. It doesn't come by itself as O, it comes as O2. Okay, so that part is better. But now we're not really happy with it because there's a law of conservation of mass. And that's why we have to balance equations in the first place, because of this law that says that mass is always conserved in a chemical reaction. You cannot create or destroy matter when you do chemistry. So at the moment, I'm trying to start with 2 oxygen atoms, and at the end, I only have 1 oxygen atom. Well, I can't destroy an oxygen atom, so this is just not right. What I also can't do is add another oxygen. Yeah, make it a no. Because we already said oxygen comes in pairs, doesn't come by itself, so we can't do that. Another way to get around this and use that second oxygen is to MgO2. Now we're using 2 oxygen atoms, so yay, except not yay. This is actually not the correct formula for magnesium oxide. The formula really is MgO. Now, I happen to just know this, but what if you didn't know it? Let's look at how you might work that out. You would look at what you start with, magnesium and oxygen. Now, there are a couple of ways to work out what the formula for magnesium oxide is. I'll do it the long way first. Magnesium is number 12 on the periodic table. This says that it has an atomic number of 12, which means it will have 12 protons. However, because it will have 12 protons, it will also happen to have 12 electrons. So let's put those electrons into their shells. The first shell can take 2, it's full, so we move to the second. 8 fills up the second shell, so we move to the third. We've only got 2 more to put in. Those 2 will easily go into the third shell. So this is what we call the electron arrangement of magnesium. Let's do oxygen. Oxygen is number 8 on the periodic table, so 8 protons, therefore 8 electrons. 2 in the first shell, 6 quite happily into the second shell. Now, why did these 2 react in the first place? To get 8 valence electrons. That's why atoms react, to get 8 valence or outer shell electrons. At the moment, magnesium has 2 outer shell electrons and it wants 8. So what the magnesium actually does is kicks these 2 out. If they're not there anymore, let's kick them away. Now its outer shell has 8 valence electrons, and that makes magnesium stable. So that's what atoms are trying to do, that they need to get stable. Oxygen needs to gain 2 electrons. Well, guess what? Here are 2 right over here. So those 2 electrons that magnesium wanted to kick out, oxygen says, hey, I'll take you, I'll pick you up. So they're not out in space anymore, they are with the oxygen atom. And oxygen now has 8 valence electrons. So far, so good. These atoms are now stable. But in kicking out the 2 electrons, magnesium lost 2 negative charges. So what was left behind overall was positively charged with the 2 plus charge there. Oxygen gained those 2 electrons, so it picked up 2 electrons, it picked up 2 negative charges, so it becomes O2 minus. These are now ions. An ion is a charged chemical species, either an atom with a charge or a group of atoms with a charge. So these are ions, the magnesium ion and the oxide ion. You'll note the ones that finish with a negative, we change the name and we finish with IDE. So it's the magnesium ion and the oxide ion. It's not the oxygen ion. Anywho, we now have opposite charges. And what do opposite charges do? They attract. So it's this attraction between the magnesium and the oxide that forms our product. So we write magnesium oxide. Now, compounds don't have a charge. If we put this magnesium ion together with this oxide ion, we can see that because we have a 2 plus and a 2 minus, all of the charges will cancel out quite nicely. And that's what we want. This magnesium oxide, our compound, doesn't have a charge. But we've only needed one magnesium and one oxide to cancel out all charges. So we can just throw them together and call it MgO. That is the formula for magnesium oxide. A quicker way to get to the ions formed is to look at where they are, magnesium and oxygen. Magnesium is in group 2 of the periodic table. Anything in group 2 forms a 2 plus charge. Okay, and then we look at where oxygen is and we find it in group 16, and anything in group 16 forms a 2 minus charge. And then we can see, okay, we've got a 2 plus, a 2 minus, they will just come together, all the charges cancel out, grand. So again, we've got our MgO as our formula. So back to the equation. We can't make it MgO2, that's not the formula for magnesium oxide, MgO is. But what we could do, because remember, we're trying to actually use up another oxygen. Well, let's just have another magnesium oxide. Surely that will use another oxygen because this magnesium oxide at the top uses one. But if we had another magnesium oxide, that would use another oxygen. We've used our 2 oxygen atoms. So oxygen is now balanced. Great. Except we tend to not really write MgO plus MgO. You don't say apple and apple, you say 2 apples. So let's put a big 2 in front of the magnesium oxide to say that we have 2 of this thing. Okay. Remember the small numbers in subscript, how many atoms in that molecule. But the big number in front, how many molecules of that compound you actually have. So this is actually saying we have 2 molecules of magnesium oxide. Each molecule uses 1 magnesium and 1 oxygen atom. Okay, so the oxygen was balanced. Unfortunately, now we've messed up the magnesium. It was balanced before, but now it's not. We actually need 2 magnesium atoms. That's okay because we can just start with 2 magnesium atoms. This is now a balanced chemical equation. A little bit messy one on my screen. But what we actually have is 2 magnesium atoms react with 1 molecule of oxygen, because remember there's a 1 in front there, but it's like algebra. We tend to not write the 1s. And that forms 2 molecules of magnesium oxide. That is now a balanced chemical equation. Anything on the left of the arrow is present somewhere on the right of the arrow. So I start with 2 magnesium atoms and I finish with 2 magnesium atoms. I start with 2 atoms of oxygen and I finish with 2 atoms of oxygen. So I haven't tried to create or destroy matter, it is balanced. So that equation is now correct. Let's look at a few more. Now, these next examples, we're not worrying about how to write the equation, we've just been given the equation. And so we just need to say, oh, how many of each molecule do we actually need? All we're going to be changing is the numbers in front of the chemical species. When you're given an equation and asked just to balance it, don't try to change the formula of each compound. So all we're going to do for this is change the numbers in front, right? We're not going to change it. Like this says that nitrogen reacts with hydrogen to form ammonia. And that is all correct because nitrogen is a diatomic gas. Hydrogen is a diatomic gas. Ammonia, the formula really is NH3. So we're not going to play around with any of the formula we've been given. We just need to know how many nitrogen molecules do we have? How many hydrogen molecules? How many ammonia molecules? So let's start balancing. We need to start with 2 nitrogen. At the end, I've only got 1 nitrogen. Well, let's have 2 of those molecules because now that uses 2 nitrogens. So nitrogen is balanced. Move to the next one, hydrogen. I start with 2 hydrogen atoms. I finish with 6 because I've got 3 for every ammonia. One ammonia molecule uses 3 hydrogens, but remember I have 2 ammonia molecules. So all up I've actually got to finish with 6 hydrogen atoms. So we just put a 3 in front of this, because 3 molecules, when hydrogen is a diatomic molecule, well, that's going to use 6 hydrogen atoms. And that's now balanced. That's all we need to do, because we start with 2 nitrogens and 6 hydrogens, and when we finish on the right-hand side of the arrow, our products contain 2 nitrogens and 6 hydrogen atoms. It is balanced. Another example here. Let's start with C. Well, we have 1 carbon and we finish with 1 carbon. Carbon is balanced. Let's do the oxygen. We start with 2. We've only got 1 at the end, so we need to have 2 carbon monoxides, because now I've used my 2 oxygens. But now I'm needing to use more carbon. So now I'm saying that I've actually used 2 carbons. Now remember, before carbon was balanced. I had 1 at the start, I had 1 at the end. But now suddenly I've got 2 at the end. So I have to go back and change how much I had at the start by putting a 2 there. So I've now got 2 carbons at the start, I've got 2 carbons at the end. I've got 2 oxygen atoms at the start, and I've got 2 oxygen atoms at the end. So it's balanced. Now, when you're balancing equations, sometimes this is, well, quite often, this is what you need to do, is just go back and forth a little bit, because you'll balance one of the atoms, but then in balancing the next one, that might mess up the balancing that you had already done. So you just have to go back and forth until it all works out nicely. Here's another example, bit of a longer one, but that's okay. I have 1 silver, 1 silver. It is balanced. I have 1 magnesium, I have 1 magnesium. It is balanced. I have 1 nitrate, I have 2 nitrates. That's not balanced. I need more nitrate. So, okay, let's start with 2. But now I've messed up my silver, because remember I had 1 silver and I had 1 at the end as well, but now I've got 2 at the start, so I need to have 2 at the end. So I've rebalanced my silver. Now we'll look at chlorine, because in making it 2 silver chlorides, now I'm saying, well, I needed to have 2 chlorines. But that's okay, because at the start I did have 2 chlorines. It is now balanced, okay? Because we've got 2 silver at the start, 2 silver at the end. 2 nitrates at the start, 2 nitrates at the end. 1 magnesium and 2 chlorines at the start, 1 magnesium and 2 chlorines at the end. It's balanced. So remember, we're not playing around with the different formula. When we're given the chemical equation, we just assume the formulas are correct, right? Whoever's set this question should know how to write the formula correctly. When we're balancing, we're just changing the numbers in front of each chemical species, just in terms of how many molecules of each one do you have. Right, here's another one. I start with 1 aluminium, I've finished with 2. Okay, let's make that a 2 then. So that says now that I need to use 6 bromines. Well, potassium bromide only uses 1, so let's have 6 of those. And that's saying that I need to use 6 potassium atoms. Well, potassium sulfate only uses 2, so let's have 3 of those. And that's saying now that I need 3 sulfates, and sure enough, at the end, I have 3 sulfates. It's now balanced. A couple more examples. Here we are burning, we are combusting this alkane here. This is octane. We start with 8 carbons. The only place we have carbon is here, so we're going to have 8 of them. We have 18 hydrogens. The only place we have hydrogen is in this water molecule, so we have to use 18, but each water uses 2, so we're going to have 9 water molecules. Now, in terms of oxygen, we have 9 from the water. We have 16 from the CO2, because every CO2 uses 2 oxygens, but we have 8 of those CO2. So this part, the CO2 gives us 16 and the water gives us another 9. So we have 25 oxygen atoms. Now, oxygen, remember, doesn't come by itself. It comes in pairs. It's O2. So we needed 25 oxygen atoms, so we're going to have 12 and a half O2, because that will give us our 25 oxygen atoms. This is what you will see sometimes. Some textbooks have it like this. Some websites have it like this. You shouldn't really leave it like this, though, because can you actually have half of an oxygen molecule No, of course not. You either have an oxygen molecule or you don't. So if you can't have half, you can't have 12 and a half. Don't leave fractions when you're balancing an equation. Multiply it by a certain factor to get rid of that fraction. In terms of a half, if you want to get rid of that, you multiply by 2. Okay, so what we're going to do is multiply everything by 2, and we will finish with 2 of these octanes. We will have, and I don't have much room, so I'll just write it up above, 25 oxygen atoms. Again, writing above, we have 16 CO2s, and we will get 18 water molecules. So in an ideal world, I would have more space to write or an eraser to rub my pen out. But 2 octanes will react with 25 oxygen molecules. That will produce 16 molecules of carbon dioxide and 18 water molecules. Lucky last, we have hydrogen peroxide decomposing to form water and oxygen. Now this is a decomposition reaction, so we've only got one reactant. It's just all by itself sitting in the beaker decomposing. But we start with 2 hydrogens, we finish with 2 hydrogens. So far, so good. We start with 2 oxygens. No, wait, I need 3 at the end. Okay, we're going to have more oxygen. So let's have some more oxygens at the start. Now we have 4 oxygens, and we've still only got 3, but this water molecule only uses 1. So if we had another water molecule, that would use 1 more, which would mean I'm using my 4 oxygens. So let's have 2 water molecules. I've now used 4 oxygen atoms. And now we come back and check the hydrogen. So I started with 4, and hey, great, I finished with 4. That is balanced.